All right, everybody, and welcome to another episode of the Future Ear Radio podcast. I am very thrilled to be joined today by Gabby Merchant. So, Gabby, thanks for being on today. How you doing?
I'm good. How are you? Thanks for having me.
Absolutely, doing well. So, you and I met at the Missouri Academy of Audiology show, the West meeting in Kansas City. Shout out to Liz Femler, who is the president of MAA this year and is doing an awesome job, with corralling the troops and getting, a lot of people back into the fold here in the Missouri Academy. But you were one of the speakers there, and I had the opportunity to get to know you a little bit and thought that you would be a great guest on the podcast. So why don't we kick off with just some introductions? Do you mind sharing a little bit about, your background, how you came into audiology, and, kind of the path to Boys Town, more or less?
Yeah, for sure. So I am originally from the East Coast. So I'm a New England girl, and I had kind of an atypical trajectory into the field in that I didn't kind of start out thinking I was going to be a speech language pathologist, which I feel like is the default for many audiologists, and then go to a undergrad ComDisc program and kind of find my passion for audiology along the way. So I went to a small liberal arts college in Western Massachusetts called Smith College, and I had some exposure to audiology prior to going to college, just in that my aunt was an audiologist, and I had a guidance counselor in my high school whose son was born with hearing loss. And I just remember hearing her talking about kind of their experience with that. And he actually, him getting hearing aids and things like that. I just always was kind of intrigued by it, but was not thinking like, I want to be an audiologist at that point. And when I got accepted to Smith, they accepted me through a program called STRIDE, which stands for Student Research in Department. And they basically pair you with a research mentor starting your first year. And so I had a pretty unique opportunity to start doing research really early on in my training. And so as an undergrad, before my first year even, they sent me this long list of like projects that different professors were involved with, and you had to like rank them and send them back, and they would pair you with a mentor. And there was a project on that list at Clark School for the Deaf, which is an oral school for children who are deaf and hard of hearing in Northampton. It's like adjacent essentially to Smith College. And there were a couple professors there, Jill and Peter de Villiers, who were studying kind of theory of mind in deaf children, psycholinguistics in deaf children there. And so I was like, oh, that sounds interesting. Like it just kind of like elicited some of my memories of like my aunt teaching me sign language when I was young and things like that. And so that's what I put down as like my first choice. Didn't really put that much stock into it, how it would unfold. And I did end up getting paired with Jill and Peter. And Jill was my primary mentor, and she was just amazing. And so I got to do research at Clark School starting really early on. And so I was exposed to a lot of kids with cochlear implants, with hearing aids. I met an audiologist there, and I was so intrigued by like the merging between like pediatrics and healthcare and technology and science. And like, I just got really interested, and I said, Jill, I want to be an audiologist. And she was like, okay, but you ask a lot of questions. And she was like, I think you should consider a Ph.D. And I was like, nope, I want to be an audiologist. And she was very convinced I would not be content as a full-time clinician. And we didn't have like an undergrad ComDisc program at Smith. So many liberal arts colleges don't have like a speech and hearing science undergrad. So I was a psych major at the time. And she found this Ph.D. program called the Speech and Hearing Bioscience and Technology program, which was a joint program between Harvard and MIT. She was formerly at Harvard, so she like got it from like an email and a listserv, and she was like, Gabby, look at this PhD program. Like, it's perfect for you. It's got a big clinical focus in audiology and hearing science, but it's a PhD. Like, I think you'd love it. And I was like, okay, kind of intriguing. And so she was like, okay, if you're interested, you can't be a psych major. Like, it's not going to prepare you. This had like a huge engineering focus because of the MIT half of the program. She's like, I think you need to take some engineering classes. And so I waltzed into the engineering building at Smith, not knowing anything as a sophomore. And I found a random door of a faculty member that was open. And I knocked on the door, and she was having office hours. And I was like, hi, I'm not an engineering major. Like, you don't know me, but I'm really interested in this like very small, specific PhD program that you've definitely never heard of. But I'm looking for some advice on what courses I should take. And she was like, oh, well, what's the program? I'm like, we've definitely never heard of it. But and I tell her what the program is. And she looks at me and laughs and says, I was in the first graduating class of that program.
No way.
And so I was in the office of Susan Voss, who's an amazing hearing scientist, and was in the first graduating class of SHBT. And it was so serendipitous and like Jill didn't know that Susan was there. Like she just got this forwarded email. So it was really funny. And I quickly kind of shifted my research focus from working with Jill to working with Susan. I ended up self-designing a major. So Smith does allow that, which is pretty cool. So we combined in some of the engineering courses, some of the courses I was taking in psychology and education. And Smith has a master's in deaf education. And then you also can take classes at the other 5 colleges in the kind of area around Smith. So UMass Amherst is one of them, and they do have an undergrad ComDis program. So I took a few classes from there. And so I'm like probably the only person from Smith with a speech and hearing science degree. And so I also kind of pigeonholed myself into like hoping I'd get into this PhD program because I set up the whole trajectory to hopefully get in. And so thankfully I did get accepted to that PhD program, and I did apply to AUD programs. Like I was still very committed to like having both degrees. Like I wanted to do translational research. And at the time that I was looking for kind of an AUD and a PhD, ideally a combined program, the AUD was really new. So I was looking for programs around 2008. And I think the AUD started in around 2006. And so most of the AUD programs were still just trying to figure out how to go from a master's to an AUD. And to like weave a PhD into it, they hadn't quite figured it out. And so when I got into SHBT, I just decided that like I knew I would get really strong research training there, but I was like, I'm still doing an AUD after this, or in conjunction with it if I can find a way. And most people were like, okay, we'll see about that. So I went to SHBT. I spent 5 years there. I finished there in 2014, and I went straight into an AUD program at UMass Amherst because I was convinced I would stay in New England forever. And then a couple of years into that AUD program, I ran into Lori Leibold, who is the director for the Center of Hearing Research here at Boys Town, at a conference. And she was like, what do you think about coming to Boys Town for like start a lab there? And I was like, I don't know where Nebraska is on that. Like, there's no chance, like, no way. And she was like, think about it. And I actually had a close collaborator who was an advisor on my PhD who was at Boys Town, Steve Neely. So, like, I knew about Boys Town. I had known about Boys Town since my undergrad. Like, I used to read Mary Pat Muller's work and Pat Stelmakowitz and Michael Gorga. And I was, like, very inspired by their translational research. And, like, I literally remember being like, Jill, I want to be them. Like, but the idea of like going to Nebraska was like so out of the realm of anything I thought I would consider because I was so committed to staying in New England forever. But eventually Laura was like, just come for a visit, see what you think. And I was like, okay, small field, don't want to burn bridges. Like, we'll go for a visit. We'll tell them Nebraska is not for us. We don't do cornfields. And we'll fly home back to our little New England bubble. And we got here, and I, one, was very surprised about how cool Omaha is as a city. But I remember walking into Boys Town, and like, I must have met people for like 5 minutes. And it's like this really hard thing to explain, but like, I just knew they were my people. Like, I knew I had found my place and my people. And I'll never forget that feeling. But I was like, oh no, this is where I belong. Like, the level of translational research that's done here, but like, you could just tell how collaborative and supportive the environment was. And the bridge between audiology in the clinic and in research is so amazing. And I knew I just had to come. And so somehow along the way, I got convinced that this was where I was supposed to be. So I was very fortunate to be able to come and do my externship here. So I finished my, AUD coursework, and then came and did my externship here at Boys Town. And while I was doing my externship, wrote a grant and built a lab and got to like oversee construction of a brand new lab space. And then I just very easily transitioned from being in the clinic to directing a research lab. So now I don't see patients clinically. Currently, I'm a full-time research scientist, but my research is very translational. We're recruiting patients directly out of clinic. And so I still feel like a strong connection with clinic, and do plan to go back into clinic formally at some point. But yeah, I run a full-time research lab now, studying pediatric hearing loss, which is kind of what initially got me inspired in the field. So that's cool. The very long-winded trajectory.
Very, like a lot of serendipity there. It's funny, actually, just a quick side note. The last episode that I just recorded was with an SLP at Clark School. So what are the odds there, right? And
That's funny. Yeah.
yeah. So, I mean, I'm learning about that program in that's, I guess, school system, and then like all of the online support materials that they have. But, what are the odds that, that was part of your genesis, more or less?
Yeah. And a big part. And actually, that guidance counselor I mentioned, her son was connected to, like, I think he was getting services in some way for Clark. I remember them talking about Clark, even though we lived like an hour away, like where my high school was, like an hour away from Smith. And so that was one of the linkages where I was like, oh, like, he got services here, like Clark, cool. Like, that's what the trigger was for me. And it's changed so much because it used to be like an institutional school, like kids lived there. And with technology, like, they don't need to be there, most of those kids, so the programs have changed so much. So I'm sure now I'm gonna have to listen to that one because I want to hear all about what it's playing at Clark these days.
Yeah, no, it's really interesting. But I mean, I think it kind of dovetails into a lot of what we'll talk about today, which is like, I think that there's just so much opportunity. And I think there's so much focus now on, like I keep saying, like it almost feels like that there's like this portion of audiologists that have done this amazing job of championing, the efforts behind mandating newborn screenings. And it's, it's like that was like a huge monumental effort, and it's almost kind of like mission accomplished because of, to a certain degree, like that. For the most part, newborn screenings are pretty mandatory across the country, and I think most people are at least getting that initial screening. And so I think that where it's sort of like focusing now like along the age spectrum, and I think that like for the kids that fall through the cracks or, that they aren't referred on properly or whatever, it's like this interventional audiology space seems to be gaining a lot of momentum, and I just hear more and more focus on that. So I think it's a really positive thing. So I just want to go back to your story for a little bit. So like you go, and when you're at Smith and you're self-designing your major and all this,
yeah,
and you're having to take some of these engineering classes and stuff like that. So help me understand, what was the first major that you were getting, or what was the first Ph.D., I guess, right?
Well, so Smith is my undergrad, and so I came in, and Jill and Peter were psycholinguists. So they study how children learn language and understand language and other people. So like theory of mind is basically like how does a child understand what you know? So like at what point do we understand what other people are thinking? So if like a child watches me put, a block in a bucket and they no longer see the block, like can the child know that I know that the block is in the bucket because I'm the one who put in it, those types of things. So that's theory of mind. And so they were trying to understand that and how that may differ in children who are deaf and hard of hearing. And so, which was so interesting to me, but I definitely did always have I liked math. I liked the harder sciences, if you will, as opposed to just the social sciences. I kind of liked I liked medicine a lot in general. I'm a first gen. And so at one point I thought about medical school, and I honestly was like, well, I could never afford to go to medical school because I'm paying for college myself. So, which in hindsight was not probably the best mentality, but it all turned out just fine because I feel like I found this nice niche where I was able to combine medicine and technology and science. So anyway, so I was a psych major. And then, the shift to engineering. So the engineering students that have an engineering degree from Smith, you have to start your first year. It's a very strict course sequence. And so I really just wanted to take the engineering courses that applied to hearing science, which is a lot of circuit, signals and systems, acoustics, differential equations. There's a lot of, quantitative aspects to all of that. And so Susan helped me kind of figure out what courses I would need to prepare me best for SHBT. But it was weird because I didn't have all the same background. I didn't learn to code like the other engineering students did. So I'm trying to catch up, and I hadn't done calc since high school. And so it definitely was a shift, a really big shift. And then I'm also taking these classes in education, about how we, how just general classes about hearing loss and things to consider when working with these populations. So it was a hodgepodge in a lot of ways.
Yeah, for sure. So then I guess it's really cool that you found your way to Boys Town. I'm happy to hear that the Midwest was able to win your heart over. It's I'm not surprised to hear that you had some preconceived notions that were immediately dispelled. But you found your way there, and tell us about this lab and tell us about what you're doing now. And then I think we can, that will kind of bring together all of these like pieces along the way. Because it sounds like everything sort of was building toward this lab, and it all culminated together. All of this disparate background that you have, it all kind of congealed.
It
voice,
did.
Right?
So honestly, so the first project I worked on with Susan, so I'm still at Smith, was a study, and you mentioned newborn hearing screening, which is interesting because it was kind of related to newborn hearing screening. So a large percentage of the kids that refer on newborn hearing screening, so say, 10% of kids, and these stats are old off the top of my head, so I think they're better now, but say 10% of kids refer on the newborn hearing screening. Of that 10% of kids that refer, the majority of them do not have permanent hearing loss. Like 90% of them are referring because they have leftover gunk in their ear canal and their middle ear. They've been floating in utero for, 9.5 months. And so it's this transient, basically conductive hearing loss that's causing them to refer. And so there's a lot of improvements in the hearing screening programs now where we do a second screen before discharge if we can. They wait as long as they can. They're not, try not to screen the minute the baby is born to let some of that residual mesenchyme and kind of vernix and things make its way out of the ear. So hopefully that we're not getting as many of those referrals. But that was a big interest of Susan, is could we improve newborn hearing screening programs by assessing whether there is something going on in the ear canal or the middle ear that's causing that referral. Now that wouldn't rule out a permanent hearing loss, so it doesn't necessarily change things, but if you know that there's not a conductive component and a kid is referring on newborn hearing screening, that raises red flags that this is very likely a permanent sensorineural hearing loss and we cannot lose this child to follow up, right? So my project was to use a technology that is similar to tympanometry, which looks at how the eardrum is moving, but called wideband acoustic emittance, and to kind of get some normative data in little babies. So I made measurements at a local pediatric office in newborn and 1-month-old to look at kind of how age affected these measurements, so that maybe we could utilize that to compare to kids who we knew had this residual mesenchyme in their ear, these transient conductive hearing losses, to see if that maybe is a tool that could be added to newborn hearing screening programs. So that was my very first kind of project, very focused in this area. And now I use wideband acoustic emittance in my lab to study kids with ear infections, which is another very related, condition, also basically stuff in these kids' middle ears. So yeah, it really has all come full circle in a lot of ways.
Well, I think it's so when you were presenting at the Missouri Academy of Audiology, you presented on wideband tympanometry, something that I've only heard about. I've never really understood what the methodology is and why it differs and what the, basically the rationale behind why this might be complementary to the current procedures or even superior in some ways. So for someone like me that's not an audiologist, what's the easiest way to kind of wrap my head around what makes wideband unique and maybe why it's compelling for some of these different kinds of diagnostics that you would be performing?
Yeah, that's a really good question. So if you're familiar with standard tympanometry, that's a measurement that's done very routinely in clinic where we play usually a low frequency sound and we pressurize the ear canal at the same time and kind of look at how the eardrum responds to that low pitch sound. So we assess hearing across a wide range of pitches or frequencies, low pitches, medium pitches, high pitches, right? We do that when we do our basic hearing test. We do it when we do otoacoustic emission testing, which is kind of an objective way to assess how the inner ear is functioning. We assess a wide range of frequencies when we do ABR usually, especially diagnostically. But when it comes to assessing middle ear function, we've always just done this kind of single low frequency measurement, which is interesting because, again, we're assessing all of these other things across a wide range of frequencies. And so wideband tympanometry, as the name sort of implies, is basically assessing the middle ear system across a wide range of frequencies as opposed to just that low frequency. The frequency that we test standard tympanometry at was actually chosen because it made the calibration really simple. It wasn't necessarily the most diagnostically informative frequency. It was just that at the time it was developed, many moons ago, right?
Mm-hmm.
It made the calibration easy, which made the math easy, which made the equipment easy to, develop. And that just has really persisted. And I will say a lot of the things that go wrong in the middle ear can be detected with a low frequency stimulus. So our ear, without getting too nerdy on you, like our outer and middle ear system is kind of like a mechanical circuit. And so there are like mass and stiffness effects that can influence things. So literally physically, your ear can be stiffer because, a bone is, kind of not able to move in the same way as it could because of a disorder like otosclerosis or stapes fixation, where you get this abnormal bone growth and now your middle ear bone can't move as well. So the system is physically stiffer. Or you can have physical mass added to it because you have fluid in the middle ear, which is also making the eardrum not move as easy. And so you have both mass and stiffness effects. So our ears naturally have these mass and stiffness properties, and pathologies change the mass and stiffness properties of the ear. And when we look at just a low frequency, like we do in standard tympanometry, we're only assessing the stiffness properties of the ear. We're not considering the mass or the resonance or all of these other features that could be changing with different pathologies. And by looking across a wide range of frequencies, we can look at mass and stiffness effects and resonance and things like that. And so in my head, and this is not, I don't think even how people who have developed wideband tympanometry necessarily think about it, but like in my translational head, like tympanometry is almost a screener to me. It often can tell me that there's something going on in the middle ear, but it's not really good at telling you more beyond that, like what is going on. And wideband can often be much more diagnostic. And so we can start to differentiate. There's something wrong and this looks like otosclerosis, or there's something wrong and this looks like otitis media, or a certain subset of otitis media, or there's something wrong and this looks like superior canal dehiscence, which is actually in the inner ear, and mimics a lot of middle ear pathologies. So, I think the diagnostic versus screener is
that's very helpful.
I think about it.
I mean, because the closest, like, I guess, parallel that I'm drawing here is, like, again, going back to newborn screenings. A lot of programs, they, the default method is the, otoacoustic emission, and then you fail that, and then you get referred on to an ABR, automatic brain response. And so then it's like, is that kind of the same idea here in your mind? Is that, I mean, because, like, I guess you could just default to using wideband, but do you see this as something where it's almost like you do a standard temp and then that sort of flags, okay, maybe I need to do the more advanced wideband temp, which is going to tell me more? Is that kind of the idea?
So the like OAE versus ABR, like those really test different components of the system. And so like ABR is going to tell you a lot more about like the brainstem, like an OAEs only go out to like the level of the outer hair cells. But I think ABR is a good parallel because we use as a screener, we use like a click, which is just kind of this like wideband, stimulus that really kind of tells us about the mid frequencies really well. And that's what's used in these automated ABRs that are done in newborn hearing screening. But when you have a diagnostic ABR done, we do the click, but we also do these like tone bursts. So we're looking at frequency specific responses. And so that's what I kind of think of it. It's, with wideband tympanometry, you're still getting the standard temp. You're getting information at 226 hertz, and you're getting information at all these other frequencies. So that said, the difference between ABR, where you can do a click, or all of these kind of frequency-specific tone bursts, is that the frequency-specific tone bursts take a lot longer, right? So that's why we kind of isolate. Let's pick specific people who kind of refer on our screener to get the diagnostic protocol. There's almost no difference in time between a standard temp and a wideband temp.
Cool. Okay.
And so for that reason, I don't think that we need to screen with the standard temp. I think we just make a shift from doing standard temps to wideband tympanometry on everyone where tympanometry would be indicated, because really you're going to get at least as much information as you would have gotten with the standard temp. And in cases where it's diagnostically helpful, you're going to get more information. So it's not that in every case you're going to learn extra, but in a number of cases you will, and it'll be useful in those cases.
No, this makes total sense. It's a more robust type of diagnostic. I get that you're testing at different frequencies in addition to the low frequencies. So again, just in my layman's mind, what are the kinds of things that you might be detecting with these middle and higher frequencies? As a clinician, like what are some of those things where maybe standard tympanometry is not going to, give you a clear picture of what's going on, whereas wideband will at least give you some clues. And what would those clues maybe indicate?
Yeah, that's a really good question. So there's been a number of kind of pathologies that have been identified in the literature to kind of that wideband has been identified to be sensitive to. So there's one kind of clinical scenario, I guess, where wideband seems to be helpful is in more adult populations, but I guess it could be pediatrics. If you have kind of an intact eardrum, so you don't have a perforation, there's no obvious pathology of your eardrum, and you have a well-aerated middle ear, so no fluid, and you have a conductive hearing loss, right now, the assumption in that setting is often that you have something called otosclerosis or stapes fixation, which is probably the most common cause of that presentation. But several other things can cause that. So you can have a disarticulation or a break in one of the ossicles, or you can have a fixation somewhere else in the ossicular pathway. So people can be born with like fixations of their malleus or one of the other bones. So it's not the stapes, it's, something else in the pathway is fixed. Or you can have a problem in your inner ear called superior canal dehiscence. And that's a hole in your superior canal that energy gets shunted out of. And so it's a true conductive hearing loss. But when we think conductive hearing loss in audiology, we think middle ear. People don't think inner ear. And so there are people who have SCD who had operations on them to fix their stapes fixation because it was thought that, all the test results pointed to like this person probably had a stapes fixation. They got a prosthetic put in and then like nothing improved. Their hearing didn't improve. None of their symptoms went away. And so wideband seems to be more sensitive to kind of differentiating between those pathologies. In my lab, we are really interested in otitis media in kind of infants and toddlers. So I kind of alluded to the newborn hearing screening application early on, and that's been extensively studied. People are still actively working on that, like identifying hearing loss, kind of differentiating between conductive and sensory neural very early on in newborn hearing programs and NICU babies and things like that. And I've been seeing kids who kind of are in that 6 month to 5-year-old range who get kind of recurrent ear infections or kind of a persistent state of fluid in their middle ear. So when we talk about an ear infection, I think people all think like red raging eardrum, kid has a fever, upper respiratory. That is absolutely an ear infection. I call that acute otitis media. You have this acute state of infection. Antibiotics are often indicated, but there's also something that people often say is an ear infection where there's no actual infection present. And that's when the fluid in the middle ear just kind of persists for a long period of time. And that can be the fluid that resulted from an episode of acute otitis media. But sometimes people can end up with this persistent fluid without infection because of dysfunction of the eustachian tube or allergies or all sorts of reasons. And it's those kids that I'm really interested in as an audiologist because those kids have this fluid in their ear for 3 months, 6 months, 9 months, 12 months. And often you don't even know it's there because there's no symptom other than potentially some hearing loss. Mm-hmm. And kids aren't really great at reporting. This is why the age of identification of hearing loss prior to newborn hearing screening was so late because kids aren't good at reporting that they have a hearing loss. They don't know if anything's wrong. Like,
totally.
Okay, the world sounds like it's underwater, but they don't have a comparison necessarily, or they don't have the language to articulate what's going on. And so these children are often found kind of incidentally, like they fail a screening at school or the pediatrician happens to notice that something looks weird about their ear at a routine checkup or whatever. And so those kids can be walking around for long periods of time with hearing loss from that. And our diagnostics are not as sensitive to it. So tympanometry can often tell us if there's fluid present or absent, but there's lots of variables about these ear infections and fluid in the middle ear that can differ. And so some kids with fluid in their ear have absolutely no hearing loss. And some kids have 50 dB hearing losses, so moderate hearing losses, and kind of everything in between. And so I've been really interested in how wideband might be able to help us understand kind of how much fluid is in the middle ear, how does that affect their hearing, kind of what are the characteristics of maybe that state that might suggest that it's going to persist for a long time. Like if we could predict that fluid's going to stay for a long time, then we might say, this child needs tubes. But if we could say, oh, this is one that's going to clear really quickly on its own, we are not going to want to send that child to surgery as quickly, right? So those are the types of things that we've been looking at and finding that wideband is sensitive to at least some of this variability because it's so much more sensitive to variations in kind of the broad mechanics of the middle ear. So that's another, and I think, in pediatrics, that and newborn hearing screening are the two biggest applications because for ear infections, they affect such a large percentage of children. Like there's a huge, I think, population of kids that could benefit from improved diagnostics in this area.
For sure.
Yeah. So those I think are like some of the big ones. There have been studies that have looked at things even like increased intracranial pressure right now, which has to be monitored with like a shunt in your skull. But intracranial pressure can also change. It's been shown to be able, you can actually measure changes in intracranial pressure in your ear canal because of how it changes the pressure in your middle ear space. And so Susan Voss has looked a bit at that and looking at both wideband tympanometry and otoacoustic emission. So there's some really interesting applications like that for it as well.
Yeah, no, I think this whole thing is it's absolutely fascinating that in 2023, it feels like we have relatively robust diagnostics. Again, to your point, prior to the discovery by my namesake, Dr. David Kemp, the much more famous one, who discovered the otoacoustic emission, how do you objectively determine these things? So it's cool that there are these anatomical functions of the body that really do sort of tell a story. And what's really cool though is that there's still so much more that we haven't fully learned and that we continue to learn, and that with today's medical technology, you have the ability to kind of discern this information. So I imagine as an audiologist, as a researcher, that's got to be really, really exciting. I want to go back though, now that I have a better understanding of where your road ended up. I'm curious, I get you obviously had this kind of meandering journey that led you to Boys Town, but why did you initially glom onto wideband tympanometry? What was the impetus for why that became the more or less your passion?
Yeah. So and I do use more than wideband tympanometry, but it has been the thing that has followed me kind of throughout my career, if you will. And part of it is just that it's what I had expertise in. So when you get a Ph.D., you're becoming an expert in something, right? And so as an undergrad, you don't have a lot of say in the projects you work on. So Susan had a funded project and you're a student. So you do whatever your mentor is working on. And so that's one of the projects she was working on. And I really wanted to do something very translational with human patients, and that's what we could come up with that was funded under whatever funding she had at the time. And then when I got to SHBT, I wanted to work with humans. And so the labs at Peabody many of them are very basic science labs. So they use animal models. And I tried to do an animal lab and I literally cried sacrificing the mouse. I just can't do animal research. I learned that about myself very quickly. And there were honestly limited labs where I could do work with humans, and I still wanted a really basic science piece. So I ended up doing research in human patients and then simulating patients in cadaveric preparation, which didn't bother me at all because the person had already passed and donated. Exactly.
But the little mice, the pygmy mice, you
can't do it.
Can't do that.
Can't do it. Mice, chinchillas, and I'm so grateful for animal research. I think we can learn so much from animal models. So this is not I actually am involved now with a cross-species studies where we're using an animal model. My best friend was doing animal research at the time. It's very valuable. I just personally could not do it myself. And so there were limited options on projects that I could work on the auditory system, on humans. Plus, in addition, though I think you can absolutely be an audiologist and a hearing scientist who does basic research in animal models, I wanted to do very translational research. I wanted to take questions from the clinic and study them in patient populations. And so that's just where I felt my passion was. And so being able to work in human populations. And so the lab I ended up in with Heidi Nakajima and John Rosowski and Samuel Merchant, which is actually the lab that Susan trained in, which wasn't she wasn't you have to go to my lab. It all kind of fell together. They were just starting to get interested in using wideband in their lab. And so I had this experience with wideband from working with Susan. And so it kind of became a good fit that we would learn how to kind of study and learn more about wideband acoustic emissions or wideband tympanometry together. And I could utilize what I had learned about it already to benefit the lab in some ways. And I had access at Mass Eye to the most interesting patient populations, right? Like they see the most unique patients. Like I was able to study superior canal dehiscence, when there were not cohorts of these patients at like any other hospitals other than maybe like Johns Hopkins. And so to be able to study kind of wideband in these very unique patient populations where it could be beneficial to have access to those patient populations was so unique and really cool. But my passion was always peds. Like I wanted to get back to pediatrics. And so that lab was studying adults. And so like Boys Town sort of allowed me to like bridge everything where I was like, okay, now I can really get back to pediatrics, but utilize everything I've learned about wideband and apply it to this population of children who also have a conductive hearing loss or a conductive pathology going on, where I think wideband would be beneficial. So.
Okay, so you've mentioned the term translational, like a translational lab, which was something that I wasn't totally familiar with until we met and you were telling me about what that means, like particularly in the Boys Town setting. So I think this is really cool how Boys Town sort of allows for you to kind of take the research and then immediately apply it. But can you speak to like how Boys Town is designed and, from this standpoint with the translational lab piece?
Yeah, for sure. So I think people define translational research in a number of ways. And so it's kind of one of those buzzwords. So like I think about basic science research a lot as like the bench work, the animal models, the, people in labs with beakers and, that type of, but what you think of as that. Though there's certainly basic science research that happens in humans, asking very basic questions about mechanisms and things. Whereas translation, I think, like you said, it's like there's this question that came up in clinic and now I'm studying it. So, but it's not like an intervention necessarily. That's like a next step where you're really applying it back to the clinic. So it's, I don't know, to me, it's like kind of that bridge of like, they're very clinically driven questions that you're then studying, even though like some of the questions I'm asking in my lab are probably more basic, like how does fluid volume influence hearing loss in otitis media? That's probably a more basic question, but I'm studying it in a very translational way. So I don't know. The terms are all like very interchangeable, but, coming from a place that was like amazing at basic science, but didn't have as much translational research. Like when I recruited patients at Mass Eye, I was recruiting them primarily from our otolaryngology clinics. There were several otolaryngologists on staff who like had labs, collaborated with labs. There was a lot of interest in otolaryngology, but there wasn't like a strong tie with audiology, the audiology department at the time. And so the otolaryngologists were amazing. I benefited so much and learned so much from them. And honestly, they saw the coolest, most unique patients. But like, I wanted to be an audiologist. Like I wanted to study hearing loss. And so like that tie to audiology, I hadn't experienced a place where with a very strong bridge to audiology, I guess, if you will. And so I like coming to Boys Town was amazing because there was this incredible bridge between our audiology clinic and research. Like all of our audiologists have like this city training, it's called. It's like a biomedical research training so that they can help in research labs, consent participants if they need to. Like they literally support the research program in that way. They help recruit patients. Like if we have protocols we want to roll out in clinic to like test them out, like that's something that they will collaborate with us on. Like, many people on staff like have a role in research and in clinic. So we have multiple people who like are part-time clinic, part-time research. And so that bridge between audiology and research is just so strong. It's not like you're just coming and knocking on their door and being like, hey, can you help me recruit participants? Like, and there's nothing in it for you because like they really believe in the research program. Like we have a lot of these like lunchtime talks where like the audiologists come, their scientists come, like it's just so integrated. And I am certainly biased, but I honestly think it's the best place to do translational research because you don't, like, it's hard to do it. It's hard to recruit patients. Like it's hard to recruit these populations. So if you don't have access to the clinic, you don't have buy-in from the clinicians, like you can't do it. It's like banging your head against a wall. And so as a scientist and an audiologist, like to be able to bridge my worlds like that in a way where like that infrastructure already is there with just people who are genuinely passionate about improving hearing healthcare and advancing hearing healthcare, like it's amazing.
So like, are these types of translational research, translational lab, these kinds of settings, are these typically where like the forefronts of like new diagnostic procedures in general sort of spawn from? It's like the research, and then it's kind of like it starts here, and if it's successful, then it kind of cascades to other clinicians, because to your point, they're not maybe as well equipped to I don't know, trial these new diagnostic methods. And then so it's almost like you're kind of validating for the field, here's an entirely new method or procedure.
Yeah, I mean, that's exactly it, right? And so when you get to the point of a clinical trial, like it's usually places like this, unless it's like an industry company who's like running a clinical trial for like an investigative drug or something. But yeah, I mean, like Boys Town had a big role in both OAEs and ABRs, like establishing normative data sets. And, and that's a relationship between clinic and lab, right? Like that is, that was Michael Gorga and Pat Somakowicz did a lot of that. And so they bridged, like they actively saw patients in audiology, like their offices were in the audiology clinic, but they also like ran research labs. And so I think that is exactly what happens. It's like we think about it with evidence-based practice, like we are trying to build the evidence to then provide, clinicians with that evidence base so that they can practice using that evidence base. And so, but you need the clinicians to be part of that. Like you need people who are full-time clinicians who are actively seeing patients, who are hearing certain complaints from patients, or who are testing these protocols. Like there's so many things that like are developed in research that they're like, this will never fly in a clinic. Like I don't have an hour to do this speech recognition test. Like there's no way that's clinically feasible. And so when you're not a clinician and you haven't worked in clinic and you don't have that like in the back of your head all the time, or a clinician like in your ear testing out, like, we really need the clinicians to be like, yeah, this is not feasible, or like kids can't do this, or what have you. And so you need that bridge to facilitate a lot of that. I don't know if that answers your question.
No, that totally does. I find this to be so interesting, is where do these new methods and diagnostics come from? And I think that makes a lot of sense, that it would start as research, obviously, and then like where are the first implementations at the clinics. And I think that this helps me to better understand like what makes like an institution like Boys Town so unique, is this like translational piece, which I feel like as a researcher, that's got to be a really exciting environment to be in, because it's like not just you, but it's all of these other sort of translational fields that are, in the midst of sort of like undergoing this discovery of like, are we at the forefront of all of these different kinds of methods and procedures? That's got to be just I feel like a really exciting, for somebody that has that kind of aptitude, that is sort of like this scientist that is trying to kind of bring things to life. That's got to be, I think, a really exciting setting.
Super exciting. And there is great basic science that happens at Boys Town too. I think like our translational research is kind of what makes us so special and unique in a lot of ways, but there's certainly a lot of basic science. And actually I think wideband tympanometry and wideband acoustic admittance is like a really good example, because Doug Keefe, who recently retired from Boys Town, but was at Boys Town for many, many years, like his basic science research, like really is what created wideband tympanometry. So like what is in the interacoustic Titan device and now the GSI TymStar, like the math behind wideband tympanometry, which is real complicated. Like I understand why they were like, ooh, 226 probe tone, this is simple, let's do this. Like the math behind wideband tympanometry is super complicated. The calibrations are super complicated. Like it is not a trivial thing. And he did, years and years and years and years and years of development to like figure that out and make it happen. And so like, it's also really cool to be someone who now is studying wideband, but also in a very like trying to really figure out like, okay, how do we get this into the clinic? But like to have this deep appreciation that I could do none of this had it not been for the work of this person who's been at Boys Town for all of these years, right? So like that came, and it was, there are other people at other places who have significantly contributed to kind of wideband tympanometry and wideband acoustic admittance being where it is. And Susan was on a lot of the early work, John Allen, like a lot of people have contributed, but like having someone at Boys Town who was such a big contributor to that was really special and cool too. And it's nice to be able to kind of hopefully continue pushing that work that he spent.
Standing on the shoulders of giants.
Literally standing on the shoulders of giants. So seriously big shoes to fill, which I will never fill. But it's not, it's special to like see it really all come full circle like that. But over like a 30-year time span.
Mm-hmm. No, that's really cool.
It's slow.
So like it seems like, you're kind of still just getting started. Like I know that you've built the lab and like I'm sure it doesn't feel like you're getting started, but it seems like you're kind of at the earlier portion of your career and your journey and all that. So like, where do you sort of see the next, phase of your career as like a scientist? Like what's next for you if not saying like after Boys Town, I'm just saying in general, like with what you're focused on now, obviously you're kind of in the midst of doing a lot of this work around wideband tympanometry. Do you have kind of a line of sight into like, I really hope that I can achieve this phase and then that would allow for me to move on to this thing. And I want to explore this facet, whether it's with wideband or if it's with something related. Like what does the future kind of hold for you from that standpoint?
I think, if by the end of my career, and I would agree that I'm very much on the earlier end of that career, if we have transition to using wideband instead of standard tympanometry, like I will feel
mission accomplished,
right? But realistically, like I think that transition, that like really to see it like regularly implemented in clinic might take my whole career. And not that that's the only thing I'd be working on, but like, so throughout my career, I hope to find ways to contribute to that in both like kind of academic research ways, but also in doing things like coming to the Missouri Academy of Audiology and talking about it. Like, really translating to clinic means like boots on the ground with the clinicians. And so, I can go to these big research meetings, but like most audiology clinicians do not have the funding or time or support to be able to be going to the big meetings. And so I really think it's like state meetings. I did a mini course for interacoustics, like things like that, where I'm hoping can provide some education and training and like, so doing things like that, I think will continue to be something that feels important to me and helping translate. Because ultimately, like I can do all the research I want and publish all the papers I want and get all the grants I want. But like, if it never gets applied to clinic, then what's the point? So
have you felt like, that you're making some headway in that regard, that you're getting positive reception from clinicians that are at least inquisitive about this and saying, please tell me more. And I'm interested in, I'm really interested in what you're doing.
I think so. I think we're starting to see more uptake. So, it's new equipment. For most people, it requires buying new equipment.
Mm-hmm.
Up until very recently, there was, only 2 devices on the market that were FDA approved that could do it. And one of them does not pressurize. So just as wideband acoustic emittance at ambient pressure, it doesn't do the pressurization, which I think for clinicians is going to be important. So really, it was just the Titan that I was seeing people use. And so if you didn't have a Titan, you can't do it. And so, people aren't learning about it during their Au.D in most programs. Right. And so I think that that's part of why it's been slow. But yeah, I feel like even like after the Missouri Academy of Audiology meeting, I had a few emails with people who are like, okay, what do we need to do this? Like we should be doing this. And so talking about like, well, here's your equipment options. And, I have some relationships with some of the people in the companies that, are supporting and selling these devices. And so just making sure that they feel like they have what they need to talk about the advantages of it. I mean, it's new to a lot of them too, right? Like all the manufacturer reps, like, and so, yeah, I think, that'll be a big piece. But the other piece is that broadly, like as much as I use wideband in my research, like my research program as a whole is not just about wideband tympanometry, right? So I am really interested in improving diagnostic tools and kind of figuring out how we can individualize healthcare, get more objective measures for pediatric populations, because those are the populations that are often pretty difficult to test. So, a 10-year-old with an ear infection, we can do a hearing test on them and understand how they're hearing very easily. They can raise their hand when they hear the beep. But, an 18-month-old does not raise their hand when they hear the beep. And though we have a lot of strategies to test kids clinically, there are still limitations to those, especially if you want to get like really understanding how each ear is hearing. And so the better objective measures we have that can tell us kind of what's happening in the ear and how kids are hearing would really improve healthcare generally, but also like if you think about places where you don't have a boys town down the road, so rural clinics, like, you know, they don't have pediatric audiologists and play partners and all this specific expertise, but if they can put a microphone in a kid's ear and say like, this is how this kid is hearing without the kid really having to do anything, without a lot of extra time and resources, that could be really powerful at improving kind of healthcare broadly.
Yeah, I mean, I agree with you that it seems that that's sort of the macro theme right now with healthcare is this move toward more personalized medicine in every kind of way, shape, and form, including the diagnostic procedures. So it seems like this kind of bodes, you know, or I guess it jives with the broader push in that direction. And it's cool to kind of hear specific applications of that within this industry. So I think that's really interesting. And I'm sure that there's still, again, there's so much more that we can learn. And there's, you know, like you said, the fact that like wideband has existed for a while, it's only available in a select few amount of pieces of equipment today. But I think that like, it's kind of it probably is a little bit of a chicken and an egg thing where it's like, there needs to be demand. And how do you generate that demand? Well, you need to have the people that are actually doing this today in something like a translational lab that are showing evidence of like, this works. There's a lot of interesting things that you can find. And then, you know, then the manufacturers might be more incentivized to make this more of their offering, you know, because I'm sure, like you said, there are trade-offs. Like it seems like it's a complex feature that you would have to add, but the benefit could just be that the type of diagnostics that the audiologist can perform are that much more robust, which I think in a real big roundabout way, it allows for the audiologist to elevate themselves in the greater standing, not just with the patients, but with the broader medical healthcare community as well.
Absolutely. And I think that, and there's so much more that we need to do to understand, like, the patient population is going to most benefit. Like, even with my work on otitis media, like, right now, kids with otitis media are kind of all lumped together in one big group. But there's so much variability in how an episode of otitis media is affecting an individual child. And we don't really consider that at all in our, diagnostics and our management. So some kids with OM, like, are likely going to end up with some sort of speech and language problem down the line, problems with binaural processing, which means they're not going to hear speech and noise as well in the classroom. Like, they're going to have trouble localizing sound. But it's a subset of these kids, and we don't know how to identify that subset, and we don't know what the features of those kids are yet. And so if we could figure those out, so we have to understand what that subset is and how that subset looks, and then can we diagnose that subset? So it is a chicken and egg in some ways, but I think as we learn more, so for me, that's a big piece of my puzzle, is figuring out who are the kids with OM that are most at risk for these long-term deficits. And then how do we identify them early on to make sure that they're getting intervention as soon as possible, right? So it's not all kids with otitis media that are going to have these problems. And so, but if we knew that a child was likely to end up with these problems because of our diagnostic tools, then it would be such a bigger justification to get tubes placed, right?
Totally.
Let's resolve this as soon as possible in this child. Let's monitor this child a lot more closely. Right now there's still I think we do the absolute best. Our pediatricians, our ENTs, they do the absolute best to decide how to manage kids with as much information as they have. I just want to give them more information so that they can individualize it even more.
Love that. Very cool. So as we come to the close here, for people that are listening that want to learn more, they want to get in touch with you, what's the best way to connect with you?
Yeah, so my lab has an Instagram. It's the TAP Lab, I think is I should know the act. But anyway, we're on Instagram, the Translational Auditory Physiology and Perception Lab at Boys Town. And I'm linked there. There's a lab website too that we're not as good at keeping updated, but my email's on there. I love talking to people about wideband, about my research. I love doing guest lectures on wideband for Au.D programs so that, again, students are getting some of this training along the way. But yeah, I am happy to always chat if there's anything that's of interest, or if someone has an atypical trajectory to audiology or is considering not following the very traditional trajectory. I also love talking about that. Sometimes people are like, you did an Au.D after your Ph.D. Like, that's so weird.
That is, I don't think I know anybody else that's done that.
There are very select few people. I know a few. I'm not the only person out there, but they're few and far between. And so it all worked out
It all worked out. I'm curious, like in your lab now, like how many people work with you in your specific lab?
Yeah, so I have an amazing research audiologist who's been with me since day one, Sarah Osseling, who is the only reason the ship sails. And then I really am very fortunate to have a part-time research audiologist who spends the rest of her time in clinic. So she actually was one of our Au.D externs who stayed on, and she spends, the bulk of her time in clinic, but 12 hours a week she's spending in my lab, and that keeps my tie to clinic really, really strong.
Nice.
Since the lab opened, we've collaborated closely with an ENT, Dr. Tempero, and so he is both he helps us recruit, but he also contributes a lot to our scientific ideas and, thinking through the otolaryngology piece. I'm not an otolaryngologist. Those things we study are very otolaryngology related, and so that input is really important. Another really cool thing about Boys Town, right? I've got audiologists in my lab, I have an ENT in my lab, and then I have an Au.D extern. So Boys Town's externship program has an option to do a research track to it. And so I have an awesome Au.D extern who started this summer who will spend part of her externship working in the lab. And then I have a research assistant who is an undergrad, actually psych major, like I was once upon a time. And we'll be probably hiring another RA in the near future. So Boys Town labs are a little bit different than, labs at universities because we aren't at a university, so we don't have access to undergrad and graduate students quite as readily. But still lots of amazing people that work with me. And honestly, I couldn't do any of this without them. So plus the support of our research program as a whole, our audiology department, our otolaryngology department, so many people contribute to the stuff that I do.
Well, it has to be pretty awesome if it was able to sway you away from your beloved New England home. So
it is. It's a very special place. And New England and Boston will always have a very, very, very special place in my heart. And it's also COVID, if anything, has taught me how easy it is to collaborate virtually and remotely and from afar. And so there's a meeting that I have once a month that includes Susan, my undergrad advisor. My PhD mentor is usually on that call, Heidi Nakajima. I still collaborate with Heidi and Susan. My atypical trajectory, as atypical it was, I am still very close with everyone. I text with mentors from my Au.D.
I was going to say, it seems like you're so very close with all of these people.
Very close. The field is small, but I also just think that my journey came so full circle in my lab that I still do things that apply to all of these people in different ways. And so it keeps I have all my New England ties are still very strong. And so it's nice. I get to still work with and talk with all of these amazing people who made me who I am, really.
That's awesome. Well, on that note, Gabby, thank you so much for coming on today. I've thoroughly enjoyed your story. It's an interesting one, a little abnormal, but I think you found the right home for you in Boys Town and what you're doing. It's really, really interesting, and I'm excited to kind of continue to monitor it and see the progression. Now I know a little bit more about wideband tympanometry.
I'm so glad. Thank you so much for having me. I know I was a little hesitant that I'd have nothing to talk about. Somehow you found things for us to talk about.
And here we are an hour in, and you captivated me. So I think I think you're more than capable of speaking about your very interesting life that you told me wasn't interesting. On the contrary, I have to disagree.
Oh, well, thank you for having me. And I just love what you're doing in the podcast. So I feel fortunate and humbled to be able to be a part of it.
I appreciate that. And on that note, thanks for everybody who tuned in here to the end. We will chat with you next time. Cheers.